Okay, this is the last lesson in this unit. We're going to look at compound interest. Compound interest is really what they use in a more practical sense in the real world. Simple interest is great. It gets us to understand what interest is all about. But in the real world, we actually use compound interest in 99% of the cases. Compound interest builds differently than simple interest. We talked yesterday that simple interest, you calculate the end of your period. What happens after 5 years? You make a single calculation at the end of 5 years. But compound interest, what we do instead is we reinvest at the end of each compounding period. So that way when we make a new calculation, we're calculating interest on not only the principal we started with, but also on interest we've already made. So it keeps getting reinvested. So look at an example just to give you some idea of what's going on here. So go back to that idea of we have 100 bucks, we're going to invest it for 5 years at 5%. So I equals P, R, and T. We make one calculation at the end of 5 years. We made $25. We now have 125. Compound interest, on the other hand, will take that same idea of the $100, 5%, 5 years, but instead of calculating at the end of 5 years, we're going to calculate at the end of each year. So after 1 year, we still use that equation I equals PRT. Okay, so 1 year, $100, 5%, so 100 times 0.05, but times 1 will give us our $5, which means we now have a total of 100 plus 5 is 105. So when we start the next year, we're now starting at 105. We'll do the calculation again, 105, 5%, 5% for 1 year. That makes us 5 1/4 now. And we add it in, we're up to 110.5. We start again, 110.5 times 0.05 times 1 gives us $5.51. Add it in, we're up to 150. And we do it again and again, and by the end of the 5 years, we now have $127.63. Now you're probably saying, well, that's not a huge difference from 125, but we didn't do anything differently. It was 5%, it was 5 years. The only thing that changed was how often we made our calculations. The bank did this for us. We're not doing any work. We ended up with $2.63 extra by doing a few more calculations. And the longer we leave it, the faster this is going to grow. In fact, yesterday we talked about simple interest growing in a linear way. Compound interest grows in an exponential way. So it starts off kind of slow here, this red line. Over time, it's going to start building faster and faster and faster and faster until eventually it grows so much faster than simple interest, they're not even comparable. Okay? We like compound interest as long as we're earning the money. If we're owing the money, different story, because now we owe lots of money pretty quickly. Okay, some ideas. We don't want to have to recalculate and recalculate and recalculate, so we'll use a formula to do this calculation for us. This calculation is really a geometric sequence. Okay, we have an initial value, still our principal. Okay, we have a rate, we're going to call it I. And we have an exponent to the power of n. I has its own little calculation you're going to have to do. Our interest rate, which we call our interest per period, is calculated by the rate itself, so R, divided by how often we want to make our calculations, so by big N. N is called our compounding period. So in the previous question, with our example there, we compounded it once a year. At the end of each year, we did a calculation. It doesn't always have to be at the end of a year. And we also have that N, the little exponent, and it's made up of its own calculation. Big N again, compounding period, how often you're going to do it, and T, our time in years. So in other words, little n stands for the total number of calculations. So how often you're going to do it, for how long you're going to do it for. Because the total number of calculations. So a little bit more on this compounding period, the big N thing. The compounding period, which is n, how often the interest will be calculated and reinvested. So we're going to keep doing this over and over and over again. As well as what the annual rate needs to be divided by, so how you deal with I. So we're going to come across some common things. Compounding quarterly is one thing. That means you're going to do this calculation every 3 months, once every quarter. 12 divided by 4 is 3 months, right? But there's some other compounding ones that you're going to see often. Annually, 1. Semi-annually, 2. so twice a year, quarterly, every 3 months, monthly, at the end of each month, 12 times, weekly, end of each week, 52 times, or even as much as daily, 365 times. The more often you calculate something, the faster that interest is going to grow. So daily would go much faster than monthly, which goes much faster than annually. We're going to try some examples here. So I have $1,000, that's our principal. We're going to invest it for 3 years, that's our time. At 12%, that's our rate. Yeah, but again, we're going to change it to decimals as we always do, so 0.12. And we're going to compound annually. Annually is our compounding period. Determine the amount when the investment matures. So our amount equals principal 1 plus I. Now I is made up of R divided by big N, which in our case is 0.12 divided by 1, or just 0.12. To the power of little n. N is made up of big N times T. So big N says once a year for 3 years, because it's the power of 3. Now you can use brackets with your calculator if you want to, or you can write this as 1,000, 1.12 to the power of 3. Sorry guys, to fix this writing. 1,000, 1.0, oops, not 0, 1.12 to the power of 3. Into your calculator you go, and you should have $1,404.93. So it added $400 in interest over that short period of time. Okay, we'll try another one. A GIC, it's a type of investment, a guaranteed investment certificate. Pays 6.75% compounded quarterly for 3 years. If the money is then reinvested in a mutual fund for 5 years at 3% compounded monthly, how much interest will an initial $1,000 investment have earned? So what can we write down? We know our principal, $1,000. That's what we're starting with. We got to do the GIC first. So the GIC is made up of a rate of 6.75%, or in other words, 0.0675, compounded quarterly, so N is 4, for 3 years. So how much money will that GIC build for us? Our $1,000, 1 plus 0.0675, in other words, 1.0675. Oh no, we haven't found I yet, have we? That's our R. Okay, we need to fix that. R is made up of 0.0675 divided by quarterly. Now you can write this as a fraction if you want to, or divide it out, but make sure you keep all the decimals. Okay, there's the I value, 0.016875 to the power of n, little n, again times t, or in other words 4 times 3. We're doing this 4 times a year for 3 years, 12 calculations. And that gets us a total of 122.39. We're then going to reinvest that money. So we're starting with 122.39, and it's now going to be invested at a different rate. Our rate is now 3% compounded monthly, so 0.03 compounded monthly. So I'm writing the I as a fraction this time, and I'm doing that monthly for 5 years. So my exponent is 12 times 5. I'm not always going to write it out like this over here. I can put it right into the equation if I want to. Now, to make it easier for my calculator, maybe I can simplify this a little bit. 1 plus 0.0025 and a power of 60. I end up with 1419.95. Now the question was, how much interest will we make? Well, I've got $1,400. I started way back when at $1,000. So my interest That'll be my amount minus my principal. In other words, $1419.95 minus $1,000 gives me $419.95 in interest. It's by putting in the bank, letting it earn money. Okay. Sometimes we want to know what we need to invest now. What principal do I need to put in to let it accumulate over time to get a certain amount? We call this a present value. Okay, so we'll take a look at an example and show you how it's going to work, and then we'll find sort of ourselves a bit of a shortcut, if you will. So Trish wants to buy a car when she graduates from high school in 4 years. So she's got 4 years. How much do her parents need to invest now at 8.5% compounded semi-annually to be able to afford an $8,000 car? So if we take our equation, we know we need $8,000. We don't know how much we need to put in now. Our rate that we can invest in is 8.5%, 8.5, compounded semi-annually, so over 2. So I'm going to write that as 0.085 over 2. We're going to do it twice a year for 4 years. Now, I can figure out what this big number is right here. There's nothing wrong with doing that, but I need to solve for p. So what I'm going to do instead is I'm going to rearrange this equation. Since these two things are multiplying here, p and this big bracket, I'm going to bring the big bracket over to the other side and write it as dividing. I can change my exponent to an 8, make it easier to work with. Oops, I don't need a p there, I already got one. Okay, so if you ever need to find the present value, a nice rearrangement of our equation is present value equals amount over 1 plus I all to the n. And it saves us from having to calculate and then recalculate. Our calculator should be able to handle this. 8,000 divided by, use the brackets if you want to, or if you need to, because your calculator can't handle it, 1 plus, figure out the number inside that bracket. The number inside the bracket would be 1.0425 to the power of 8. Okay, so either all in your calculator with brackets, or figure out the number inside the bracket first. Either way, you should end up with 57, 34, 31. So she doesn't need nearly enough, sorry, doesn't need near $8,000. She only needs $5,700. But over time, that $5,700 will grow to $8,000 by compounding interest. Okay, last one. Jill's parents plan to give her $10,000 on her 25th birthday. If she's 16 now, how much do her parents need to invest today at 3% compounded quarterly to have enough? So it's a present value question again. They need an amount of $10,000. They can invest at 3%, so 0.03 compounded quarterly, so divide by 4. 4 times a year, 4. She's 16 now, wants to do it on the 25th, so 9 years. If your calculator can handle that, great. If not, let's figure out the number inside the bracket. So that'd be 0.00, oh, too many zeros, 2 zeros, and then a 7.5 to the power of 36. Okay, into our calculator, and we should end up with $7,641.49. We like the idea of being on a compounder interest because they only need to put in basically 3/4 of what they need, and it's going to grow to the amount that she needs over that period of time. Okay. As I said, that's the last lesson. So some questions you should probably try to make sure you can do some compounding interest and present value. First page is interest, compound interest. Second page is present value. And that's the end of that unit.